Hi, everyone, and thanks for joining our session. I'm Ivan Nardini. I'm Senior Customer Advisor for Model Ops and Decisioning at SAS. And today, with Artem Gasgo, we are going to show you how we operationalize Spark Analytics with SAS. This is the main content of the agenda. I'll show you the two main model ops options SAS has to manage the entire model life cycles for Spark models in our analytical platform, SAS Viya. The first one is with the PMML technology, which is one of the main standard for statistical and data mining models. The other one is based on Apache Livy, which is a service to submit Spark jobs in Hadoop cluster via REST API. The session is based on an opportunity I had with an Italian customer last year. And in particular, we had a follow-up related to the Livy solution. That's why I let Artem to provide you a demonstration about that at the end. But first, why we are here today. Since I've joined SAS 1 year ago, working on model ops and decisioning, I noticed that customers can easily prototype machine learning models, but only few of them they are able to operationalize their models. Indeed, building a machine learning system may be difficult, and at the end, it's expensive maintaining it because there are some hidden complexity to deal with. About our customer, he was not able to monitor model performance decay. Indeed, models are not adaptive to the real-world changes. For example, if data change, models will break, and you will not know if you don't have a system to monitor their performance. That's why tracking model performance is one of the real challenge for model ops. Another concern was related to collaboration. They developed models in an environment with a lack of collaboration. This implies that models were not ready to take decisions. Last challenge was about retraining. As model performance monitoring figuring out the right moment, the right model in the right moment for retraining is another bottleneck of machine learning systems. To address these challenges, SAS has two integrated components in its platform, SAS Model Managers and SAS Workflow Manager. And they provide, essentially, they provide model repository, so one place to store all the models, integrated with the two building scoring engines, like CAS and MAS, both for in batch and the real-time scoring, and the possibility to integrate external engines. These kind of integrations allow us to automate all repetitive model management tasks for different type of models, both open sources and SAS models. And then, because you get a unique environment, you can assess these models in a building and customized model quality reports. Empowered with these capabilities, customers can realize the additional values. Indeed, if we assume that the model is deployed, it can receive alerting triggers for retraining and redeploy the model in the right moments, and that generates the additional value. Said that, before to show how we can achieve this result, we have this question for you. How you can operationalize Spark models? Please just type your answer in the chat. In SAS, we operationalize Spark models with collaboration. Indeed, we take advantages to open source technology like PMML and Livy Spark and enhance them with model ops capabilities thanks to SAS Model Manager and SAS Workflow Manager. So let's start and talking about the PMML options. As you probably know, PMML is the main standard for deploying machine learning models. PMML enables model development on one system system using one application and then deploying the same model on another system using another application, because it uses XML configuration file to convert these models. SAS sponsored this standard since its birth, and nowadays it has a developer communities that takes it updated compared to the new models technology. There are a lot of side projects around PMML. One of them is the JPMML Spark machine learning library, which is a Java library that essentially allow you to convert Apache Spark pipelines to PMML formats. And because our customers use Spark models, we just use a Python wrapper of this library, which is the PySpark 2 PMML package. And as I mentioned, thanks to this library, you can just fit your pipeline in your Spark session, and then you can use the PMML builder class to create the PMML file. Now, lucky for us, SAS Model Manager has the technology to deal with PMML that allow us to convert PySpark models in SAS code and provides you a SAS technology stack to accelerate scoring process in database. In particular, once you train the model and you generate the PMML version of your model, as you can see in the picture, you can register the model in a SAS Model Manager using both the user interface or the REST API. And once you version your model, you can deploy, monitoring, and retrain retrain this model in database thanks to the SAS Workflow Manager and the SAS in database technology. As I mentioned, and just as a reminder, Workflow Manager in this solution it's optional. It depends how much do you want to automate the entire process. And because our customer ask us to automate its model lifecycle, we build this workflow process. Artem will give you more details about each component, but the idea here is essentially automation. You can build this kind of process and automate all the steps of your model life cycles. So what about the pros and cons of this approach? The main point here is that you get a SAS in database technology for accelerate your scoring process. But on the other side, you have to know that PMML does not support all the algorithms coming from the Spark framework. That's why we decide to think about the plan B. And our plan B was the Apache Livy solution. So what Apache Livy is? Apache Livy is a service enables easy submission of Spark jobs or any kind of Spark code from a client to the Hadoop Spark environment. So the idea here was why we can't consider to use one of the components of the platform as a client, in particular the Spark workflow, the SAS Workflow Manager. So like we did so far, we train our models, we register the Parquet version of our Spark machine learning models and the scoring code. And then we use the SAS workflow capabilities, in particular the job execution and the REST API service to submit the scoring REST API call, gets back the scored data and generate the performance monitoring reports. And based on these reports, we decide if we need to retrain the model or we just wait to another scoring time. This is the high-level solution of what we did. So as you can see, compared to the previous one, the main thing that changed are related to the SAS Workflow Manager, because in this solution, it's It's the main component. It's our client that send the REST API to the Apache Hadoop Spark environments, and we lose the in-database technology because we manage Spark models without SAS. So as before, this is the process we built for this scenario. And as you can see, we just automate the task of scoring, performance monitoring, and once the report was generated, the user reviewed the report and decide if the models needs to be retrained or not. Finally, about the pros and cons of this second solution. Essentially, the main point here is you get a native integration. You don't have to convert the score code or manipulate it. But on the other side, you have to spend some time on Livy server configuration. So now that you know how we manage Spark model, I would invite Artem to show you how we automate the model lifecycle of a Spark churn models with SAS Model Manager, SAS Workflow Manager, and the Livy service.
Yes, thank you, Ivan. Now I'm going to show the technical scope of this topic. I will cover one of the options when we govern Spark ML model using SAS Model Manager on Viya and Apache Livy REST service. So here you can see the graphical user interface of Model Manager repository. Here we have got all models registered in our organization. Models came here from any development environment we want to use. It could be SAS, Spark, R, TensorFlow. Models are grouped into projects. We may think of projects as a scope of solving certain business problem. In project, we can have one or more models, so we can run a competition between algorithms, versions, frameworks, in order to choose champion that we will put into production. For our demo case, I have created Spark ML demo project. As you can see, here I have not got any models registered to this project. So let's do a module registration. I click import. And at this point, I have already trained a model using Spark MLlib and packaged the result, including score code and metadata, into zip format. All I need to do is to pick the location of this zip archive and click import button. Now the model was successfully registered to the project, and it was to mention that in addition to GUI approach, I can do registration, publishing, and other governance tasks with a couple of lines of code using REST API calls to SAS platform. Now let's examine the content of our model. Here is how our model looks like. We can see all necessary information about it, required to properly run it into production and reproduce it. We can have a train code, a score code, and other supporting files. On the variable tab, we can see specification of model input data and output of the model as well. On the properties tab, we will find additional information like who and when created or modified the model, what kind of algorithms used, and so on. This information would be helpful in order to get clear understanding regarding how and when the model should be used. Now let's return to the project tab. As long as we have already trained and registered our Spark ML model, we can start automated governance process. In order to do this, we should move to the Workflow tab of the project. Here, we will launch the process. We choose the process type that we want to run with respect of our project and enter some parameters of the workflow. For example, when we want to start use our model and how often we want to run batch scoring or performance assessment. Now let's talk about workflows in the details. Workflows are managed by the tool named SAS Workflow Manager. It's integrated and delivered in bundle with SAS Model Manager and provide a functionality to automate each model lifecycle task. In Workflow Manager, you can see two tabs: definitions for designing and modifying workflows, and instances for workflow administration and monitoring purposes. Let's dive now into the workflow we have just started for our Spark model project. Here we got a graphical representation of the process we just launched. What makes sense is that having such automated process, we can orchestrate both running the scripts and interaction with users by service task and user task respectively. User tasks allow us to directly interact with the roles involved in model management process. We can negotiate with developers, model validators, model stewards, and so on. And service tasks allow us to run any kind of code. We can run training, retraining processes, publishing, batch scoring, send notification, and so on. So in order to create such workload definitions, we just need to drag and drop objects located on the left panel of this diagram, fill their properties, and connect them between each other in the desired logic. So in our case, we are here have a starting point, and then we move to the timer object. When it fires up, according to our inputs, we will run a batch scoring job. Using this kind of job is an easy way to parameterize script regarding repeatable model governance actions. In this service task, we run job named run Livy script with several arguments, such as project ID and task name. Now let's look how these job definitions looks like. Here is our job definition run Livy script. Parameters, task name, and project ID that we get from the workflow will be sent directly to the Python script and Livy services. As a result, our training and scoring jobs will be executed at Spark's cluster site. After batch scoring, we are creating model performance report that will be run a health check for the model. In order to run these kind of reports, we use out-of-the-box functionality of REST API of Model Manager, just sending to the system ID of the report we want to be formed. Then we notify model steward and ask him to review these reports and decide based on that, should model be retrained or not. If model steward will not respond in one day, we will resend the notification. So we are acting as a model steward role, are responsible for model performance on the production stage. We ask it to check health state of the model. These kind of questions are becoming most important in current circumstances due to rapid changes in economy and customer behavior. In order to answer these questions, model steward should look at Model Manager out-of-the-box model performance reports. In order to create these reports, we just need to open Wizard and provide parameters like what model should be monitored and the location of the dataset model faced at the production stage. As a result, we will get this bunch of reports that will help us to track the grade of model predictive power. For instance, we can have a look at the Gini index dynamics over 4 quarters of production history, and we can see that it decays to level beyond 0.5. So based on these reports, we can answer to the questionnaire form that model quality is not good and we want to do retraining. After we choose the retraining option, the model will be trained on the Spark cluster side. And after that, new version of the model will be registered in the repository of Model Manager. Let's now switch to the Model Manager view again to our project and validate that the new version of the project was created. So that's it. We have covered a way how we can govern one certain model. But typically organizations have plenty of models. And for analytical team lead, it is good to have a big picture regarding the state of all models they are working with. In order to do that, on the same platform as the SAS Model Manager, we create Model Ops dashboard in order to address the most important questions faced by organization while maintaining models at the enterprise level. For example, using this kind of report, we can monitor model performance over all business units. By reviewing this graph, we can figure out which models are performing well and which model should be retrained. And here we can track time spent on each phase of model lifecycle and control SLA for each step, as well as overall time to market of our analytical projects. On this step, we can see workflows of our model place in production and examine the adequacy of our models and underlying hardware. Facing the fact that all models are data-driven, variable shift is one of the key indicators to track. For example, here we can see that almost half of our variables consumed by the models are at risk, meaning that they have significantly changed in their distribution. We can see exactly what variable drifted the most. It is important to track these changes in input data, understand these changes, and elaborate how models can be adapted to this change. So, as a result of implementing such automated model governance approach, you can be sure that your Spark models are getting to production in a proper way and stayed up to date with respect to the rapidly changing world. Thank you for your attention. So now we want to invite you to the Q&A session.